Okay, good morning, good morning, good morning. Just showing how I got this up in place, okay? Give me, let me just get lined up. Okay, 1 second. Okay, I think I'm there, almost there. About interview. Okay, let me just. Okay, now you'll notice that there's a lot of work now on motors, and there is, because motors are so relevant and important that each of you will learn in a different way and you will learn in a different perspective. Okay, you got to find your own style of learning and what works for you. Okay, this is just my own delivery in my style of learning and in my style of teaching. Okay, it's for you to adjust it to make it work for yourself. Okay, induction motors. Now the single phase induction motor is the most frequently used motor in the world. Okay, most appliances such as washing machines and refrigerators use a single phase induction machine, highly reliable and economical. Okay, now here, terminal box. Okay, but here you got your loops, 1, 2, 3, 4, 5, roughly I estimate 6 should be there, right? But each of these little taped up two joints is the ends of one coil of the stator. Okay, that allows you to give you that rotating magnetic field. Now, I may be wrong in my perspective of this, but do your own research for induction motors and look at the connections. We call it single phase. I have no idea why we've got 6 here, but maybe something I'm missing. Okay, but don't hold me to it. Okay, I'm only human. That sounds like the title of a song, doesn't it? I'm only human. Okay, never mind. Forget it. Never mind. Induction motors. For industrial applications, the three-phase induction motor is used to drive machines. Figure 7.2. And this is just a Siemens housing machine, okay? Siemens produces some excellent stuff, and they're still world renowned. Figure 7.2, large three-phase induction motor, courtesy of Siemens. Okay. Now let me go in a little bit closer so you can see. Make sure I get all the bits into place if I can. Okay. Okay. And this is just induction motor components. You have your end bell, you have your centrifugal switch, you have your rotor, you have your ball bearings. Now this bit here can give you a problem because when if it wears down, it will cause the rotor to touch the housing of the motor, thereby it will simply rub itself out and burn out. It will be no use to you. This ball bearing here needs to be lubricated at a point in time, and sometimes you have access for a grease gun to lubricate them, keep them well lubricated, and you'll find that the motor will run much quieter. The moment a motor begins to make noise, examine whether the bearings have been lubricated or whether the bearings have gone. Okay, stator windings. Okay, iron core with slots. Induction motors. The motor housing consists of three parts. The cylindrical middle piece that holds the stator iron core. The two bell-shaped end covers holding the ball bearings. This motor housing is made of a cast aluminium or cast iron. Now be very careful when you're dealing with these cast entities, because if you hit them too hard or you drop them, they will crack. Okay, in the aluminium case you will probably get a hairline crack that will cause you problems later on and cause vibration. With the cast iron, it will simply crack. You will see it, you'll notice it, you'll know about it. Long screws hold the three parts together. The legs at the middle section permit the attachment of the motor to a base. A cooling fan is attached to the shaft at the left hand side. This fan blows air over the ribbed stator frame. Now blows air, it draws air in from one end it simply draws air in over the stator, okay, frame structure. But we'll look at that. But again, do your own research. Make sure you add to your knowledge, okay? I'm not perfect. I'm just handsome and good looking. That is all, nothing more. It comes naturally, you just can't help it. Okay, figure 7.4 stator of a large induction motor, courtesy Siemens, okay? And believe me when I tell you, these are massive giants, okay? And there are even some bigger than these. Induction motors. The iron core has cylindrical shape and is laminated with slots. That's your iron core, okay? The iron core on the figure has paper liner insulation placed in some of the slots. Now here is your paper insulation. Now paper, but I have a feeling that plastic of some sort might now be used, but don't hold me to it, okay? But paper is still the choice of most electrical machine manufacturers. The funny thing about paper when it comes to my mind is that it tends to draw moisture, but I think these are kind of oil-soaked paper to prevent moisture ingress. But don't hold me to it. I'm only talking from memory, and you know that's a long time ago. Okay, the iron core on the figure has paper liner insulation placed in some of the slots. In three-phase motor, the three-phase windings are placed in the slots. A single-phase motor has two windings, the main and the start windings. Typically, thin enamel insulated wires are used, okay? And here we are again. Induction motor. A single phase motor has two windings, the main and the start windings. As previously mentioned, I'm just picking up from where we left off purely as a recap session. The elements of the laminated iron core are punched from a silicone iron sheet. The sheet has 36 slots and 4 holes for the assembly of the iron core. And here's your iron core, okay? Your rotor hasn't gone in yet, this is just the iron core within the stator frame, okay? Motor housing, or you call it motor housing if you like. Winding, okay? Here, this is just showing you the laminated sections, how the paper is inserted into each, and you can see your 4 bolts here that when bolted up together, compress and brings this together to form one core. I would call it the core, one core. But remember, that core is made up of laminated sheets. The elements of the laminated iron core are punched from a silicon iron sheet. Okay, they're just punched out. The sheet has 36 slots and 4 holes for the assembly of the iron core, etc. I've just mentioned that earlier. Okay, so hopefully you will now should know that by now. After repeating myself. Now look at this. Oh, hang on. Sorry, I'm just going a little bit. Sorry. Now look at this. Induction motors. Now the stator, and here's your rotor, and you can imagine the magnetic field that is set up within these here exerting a force on the rotor, causing the rotor to rotate. It has no choice. It will rotate because it's on a bearing end to end bearing, and it will drive that magnetic field within that stator will cause this rotor to rotate. And that is, I mean, you've got to admire the ingenuity of something as simple as this being effective to create a machine that gives us the means to do work. Sorry, hang on a second, let me just go back a bit. Oh, sorry, hang on. Oh, come on. Sorry guys, I just lost my way there a little bit. Yes, thank you, okay. I'm not right. It's not right, so I'm not checking in the top. Okay, right, it's okay. Stator and rotor magnetic circuit, okay? This is just showing you, as I was talking before earlier, before I lost my track, okay? You can see the gap between here is very small, okay? It's probably 1 millimeter, if that, okay? So you can just imagine that if there's any problem on the bearing, if the bearing has been worn, you can imagine that this rotor will be touching the stator, and you don't want that because that's going to cause it to punch a hole in it and your motor becomes no use to you, okay? Induction motors, squirrel cage rotor. This rotor has a laminated iron core with slots and is mounted on a shaft. Aluminium bars are molded in the slots, and the bars are short-circuited with 2 end rings. The bars are slanted on a small rotor to reduce audible noise. Fins are placed on the ring that shorts the bars. These fins work as a fan and improve cooling. Here we are. I mean, brilliant piece of ingenuity here in regards to the induction motor squirrel cage rotor concept. Rotor bar slightly skewed, okay? End rings, okay? Slightly skewed to make it easier to start because it kind of gives it off at an angle. Squirrel cage rotor concept, okay? Brilliant piece of work. The induction motors, okay, and squirrel cage rotor. Remember that here these are constructed of laminated pieces and secured together, okay? And you got your shaft here, your fan blades, okay? Laminated iron core, aluminium bars, okay? So those aluminium bars are what's skewed off completely, okay? Your fan blades, shaft again, okay? And remember, these ends will be mounted on a bearing, okay? Aluminium rings, okay? Okay. Induction motors, wound rotor, okay, most motors use the squirrel cage rotor because of the robust and maintenance-free construction. However, large oil motors use a wound rotor with three-phase windings placed in the rotor slots. The windings are connected in a three-wire Y system. The ends of the windings are connected to three slip rings. Resistors or power supplies are connected to the slip rings through brushes for reduction of starting current and speed control. Okay, now you look at this already, okay, so nothing should be on towards here. And here we are. Here's something that release rotor of a large induction motor, courtesy again of Siemens. I mean, the sheer size of these things and the weight of them has to be considerable. Okay. Okay, I hope you found this useful. Okay, have a good day. Bye bye. Well, I think it's bye bye. Yes, it is bye bye. Okay, thank you. Okay, have a good day. Bye bye.